Awesome. Well, hello. It looks to me as if we are live. Happy Wednesday morning, evening, afternoon, wherever you are in the world. Really excited to be here with all of you today for another webinar with the maintenance community. My name is Heather Grant. I'm one of the community admins here at the maintenance community. So thank you once again for making the time to join us and learn something today. If you're not already a member of our maintenance community on Slack, we would love to have you join us. I will add a link in the chat on how to sign up in just a moment. Today we have Vinoth Kumar joining for a presentation on understanding defect elimination. It should be a really awesome presentation. The recording from our session today, along with a copy of the slides that you see here, will be available in the Slack community tomorrow. Vinoth himself also is available in the Slack community to answer any questions that you may have. So please feel free to share the recording of the webinar or the invitation to Slack directly with friends, colleagues, or anyone else you know who would benefit from hearing some of Vinoth's expertise. My last piece of housekeeping, and then we will go ahead and get starting, is to use the chat on the right-hand side of your screen to ask and answer questions of Vinoth today. So we have a presentation prepared, but then we should have a few extra minutes at the end to go ahead and answer any questions that may come up throughout the presentation. Please feel free to drop them in as we go, and then at the end, again, Vinoth and I will go through and answer as many questions as we can. Anything we don't have time for this morning, for me, we will answer offline in the community as well. So please feel free, ask away, and we will get you answers to your questions. That is all from me. Thank you again, Vinoth, for being here. I'm excited for our presentation. Thank you, everyone, for making time. And Vinoth, I'll hand it over to you to get us started.
Yeah, thank you, Heather. Thanks for the brief introduction. So welcome to today's webinar. So we are going to talk on understanding defect elimination. So I welcome you all to this webinar. So from my side, it's a good morning, good afternoon, and good evening. So we have been joined across the world to spend another 40-45 minutes with me to understand the defect elimination. So myself, Vinoth Kumar Subramani, I used to work as a reliability specialist. Over around 11 to 12 years I've been there in this field. So I've been doing the advanced RAM analysis and RCM strategies for the oil and gas plants, for onshore, offshore plants, and all across the world. So I've been into the maintenance community since a long time. That I've been engaged with all the reliability activities. I've been doing it. So let us start our presentation and understand the defect elimination. So we can call the defect elimination with the two terminologies. So we can use it a defect elimination or a bad actor management. So it's a systematic process. We know that we have a lot of reliability methodologies to follow in our organization. So starting from the root cause analysis, like defect elimination, a bad actor program, reliability centered maintenance, and then the risk-based inspection methodologies, and then the FMEA and FMECA. So we are having a lot of reliability methodologies to follow around the world. So for different organizations. Coming to the point here, that today's topic, we are going to talk about one of the most interesting reliability methodologies, topic called as defect elimination. So the defect elimination is a systematic process. So it will lead to the continuous improvement process for the organization. So the input to the business process are the measurements made on the plant performance. So our ultimate aim and objective to improve the plant performance. So we need to look at that where and all we are losing an opportunity to improve the performance of the plant. So there are some key inputs we need to consider. So when we are taking up the bad actor and defect elimination program, so we need to take up the production loss data, and we need to look at the lost profit opportunity in the organization. And we need to look at the asset performance, key performance indicators, the KPIs, and then the inspection findings and the reliability findings, and audit results, and the benchmarking results and all. So why we are doing a defect elimination program? So we are having a lot of reliability methodologies to follow in our organization. So we will follow the reliability centered maintenance, we'll follow the FMEA, FMECA, we'll follow the root cause analysis, and we'll follow the reliability analytics procedures. So we are having a lot of reliability methodologies and procedures to follow in our organization and to improve the plant performance. So we know that our assets are designed to operate over a period of time, and our assets have been procured after performing the life cycle cost analysis and after doing a lot of design review assessment. So, and then we are following all the installation procedures. We are installing our assets, and we are keeping the total cost of ownership in our mind throughout the life cycle of an asset. So we are doing a lot of methodologies, but still the one of the powerful tool we can call it as a defect elimination methodology. So before getting into this tool, we need to understand the business process. So what are all the database required for doing a bad actor analysis for the organization? So how we are going to understand the risk factor behind each and every losses we are getting in the plant. So whenever we call it as a risk is all about the probability of failure and the consequence of failure. So we need to look at the inputs for inputs for collecting the bad actor database. So the inputs are come from these the key things which I mentioned here, around 5 to 6 findings. It's very important for us. So once we have been done the bad actor analysis, we can do the root cause analysis at a higher level, so that we can understand that what has caused that dominant failure mode, and so that we can understand that what will be the contributing cause and how we are going to bring out the corrective and preventive actions for each and every dominant failure mode we are finding out from our from the assets. So once we have done that, the corrective actions are to be validated and to be implemented, and we need to see the effectiveness of an assessment. So this is all about a defect elimination program. So we'll see that how to understand the defect and the failure. So we need to understand the difference between the defect and the failure. So defects can be called as an early indicator of an upcoming failure. So if you are a frontline manager, so looking after the maintenance and reliability activities in your organization, you need to have a steering team, or you need to steer a team. So who are most likely to find the defects and most able to correct them before they become a total failures. So we can consider a failure to be something that is not working now. So and a defect to be something that may lead to the failure in future. So correcting a defect in yearly many times less expensive than correcting a failure in the future. So if you are a maintenance and reliability professional, so we have a lot of frontline defense people who have been working in the organization 24/7. So we have an operation, production, maintenance. So a lot of people are working in the organization. So reliability is everyone's responsibility, but finding the defects also everyone's responsibility. That means we need to find out the yearly defects as much as possible to avoid the upcoming failures. So upcoming failures will lead to the poor asset performance, and will lead to create a create an impression that we are not maintaining the continuous improvement program in our organization. So let us see that how you are going to identify the defects. So the defect elimination program or a bad actor program, it's designed to identify the gaps present in your organization. So whatever the reliability strategy we follow, the current reliability strategies, so we need to look at analyzing the unplanned failures. So based on the impact of each failures on the maintenance cost and the planned downtime. So the maintenance cost, so the cost, how much we have been getting it from the corrective and emergency notification. So we need to look at the corrective notification and the emergency notification, how much cost we are spending on it, and what will be the downtime for each and every failures we are seeing it in our organization. So it will be based on the famous Pareto Principle. So the Pareto Principle states us that the 80% of the issues comes from the 20% of the causes. So we need to look at the Pareto Principle, and we need to frame up the Pareto. We need to frame up the defect elimination program based on the Pareto analysis. So the incidents or the poor asset performance with a significant impact on business exceeding the identified threshold are considered as an identified defect. So we need to understand that what kind of incidents we are seeing in our organization, how we are going to capture those incidents to develop the bad actor database, and to look at the bad actor identifications, and we need to have a proper data for us to do the bad actor analysis. So the equipment breakdown, and we need to look into it. The incidents such as equipment breakdown and shutdown and trips, and the unit slowdown resulting in the lost production and the major asset damage. An incident shall be reported by the operation within 2 days from the date of incident, along with the production loss capacity, so including the monetary value for the risk ranking. So we know that every incident, every failure will cost some X amount to the organization. So we need to look into the equipment breakdown, shutdown trips, and the unit slowdown resulting, where and all we are seeing the lost production opportunity because of the asset damage. So we need to trigger those things, and those triggers are the database for us to create a bad actor management program. So, and coming to the bad actor program, we need to identify the defects based on the highest failure rates and the total maintenance cost. So, as I told you that, so we need to look at the total maintenance cost. So we need to take out the list of highest failure rates, and we need to consider the total maintenance cost. It's our prime responsibility to bring out the assets into the bad actor program. So based on the failure rate and the downtime hours of each critical assets and the semi-critical equipments, we need to consider. So when you take an organization, if you take any plant which is operating around the world, so the assets are classified based on the production critical and the non-production critical. So if you are a maintenance and reliability professional, we need to understand the failure rate and the downtime costs for the critical assets and semi-critical assets, and what are the failure costs associated with those failures which are happening on the asset. And we need to concentrate on the total maintenance cost. So these are the defect elimination data logging starts. So I've presented the simple workflow how to do the bad actor defect elimination program in your organization. So if you want to implement a bad actor program, so you need to get a CMMS data. So you can use any CMMS tool for you. So we are having a lot of CMMS tool around the world. So some of the organization use the SAP, some of the organization will use IBM Maximo, some of the people may use the CMMS tool also. So we are having a lot of CMMS tool around the world. So our first job is to collect the failure history and the data. So try to get out the failure history and data. So where we are seeing all the notifications, try to get out all the PM01, PM02, 03, 04 notification, and try to filter out the notifications which are having a breakdown and emergency cost for your organization. That means the breakdown and emergency notifications needs to be filtered out first. And that's next step. Once you've done that, once you get the failure history data from your CMMS system, so then you need to find out the events. So we need to find the events. We need to find the events for an asset with an work order cost greater than 10,000 USD, and we need to look at that how many failures has happened around in a year. So we need to look at the two things. One is our work orders, another thing is number of failures. So these are the two key inputs for us to filter the data and to get out all the chronic failures which are happened to the asset, which are all happened to the plant. So once we find out once you filter out all this data, then we need to go for the next step to determine the chronic failures for the individual work orders and the material consumptions for the each and every failures which are being found out. Then once we've done that, when we need to calculate and sort out the cumulative cost for each failure for each asset. So once we have done that, then we need to implement the Pareto Principle. So once we implement the Pareto Principle, then we can understand what all the vital failures. So we need to concentrate and we need to see that how for which failures and all we need to conduct an RCA. So as I told you that to conduct an RCA, to conduct a high-level RCA, for the failures, we need to understand that how we are going to apply the Pareto Principle and how we are going to list it out the 80-20 by using 80-20 principle, and we need to filter the vital few failures for the organization. So the defect elimination program, it's not an one-time activity. It will be a continuous improvement activity. So some of the organization used to collect data for around a minimum of a year, or some of the organization may collect data for 3 years. So some of the organization may collect data for 5 years. So we need a data. So that is very, very important. So without our data, we can't able to do anything. So it's what I told you, that a workflow. So a simple workflow starts from the CMMS data system. So once we have a clear database with us, so then we can filter out the failure notifications, which are all PM01 and 02, which are corrective emergency and all. So once you have been cleared our database, so then we need to look at the work orders. So we know that the work order will be raised. So we know that the failure notification will be converted into the work order for the each and every failure we will see in our CMMS system. So once you are seeing the dominant failure modes, so which has happened to the asset, which has created the downtime loss for the plant downtime, and which has increased which is having a highest failure rate, and where we can see that highest maintenance cost has spent it on the each and every failure mode. So filtering out and clearing the database. Once we have a clear database for all the assets, so I told you that all the critical and semi-critical assets. So once we have all the database, so then we can easily find out the chronic failures. So the chronic failures, we need to understand that what kind of repetitive failures are happening on the asset. Now we can avoid the chronic failures. So we can have an improvement activity, that an analyze and improvement activity over a period of time for all the assets, so that we can try to improve the performance of the asset and the performance of the equipments what we have been dealing with over a period of time. So if you are a maintenance and reliability professional, so if you want to implement the defect elimination program, so this is how the workflow will start, and this is how we need to conduct an high-level RCA for the defects which you are finding out in our organization. So here I have represented a simple Pareto analysis route. It's 80-20. So you can see it here. So try to get out the list of failures. So we need to understand that if you have an asset, so we need to take out all the failure modes. So let us take an example. If you have a pump will have a number of failure modes. A coupling may fail because of misalignment. A pump impeller may fail because of unbalance, and a pump seal can fail because of a lack of seal flush. So a bearing may fail because of a lack of lubrication or due to high vibration and all. So try to take out the number of failures which has happened on your asset first. So how many failures have been happened? So because of the seal failure and because of the gland packing leakage, like a coupling failure, like a bearing failure, vibration. So you need to take out the number of failures which has happened on your asset. So that is very important. That is the first step you need to look into it. So once you get the list of failure modes and the number of times each and every failure mode has happened based upon your corrective and emergency notification from your CMMS system, the corrective emergency notification and the work order. So then try to take the cumulative of all those failure modes. Once you took the cumulative of your all the failure modes and the cumulative percentage of all the failure modes, then try to plot a Pareto by using a simple Excel sheet or a simple Excel program can help you to plot a Pareto graph. So once you've done a Pareto graph, you can easily find out that how many vital failures you got and how many trivial failures you got. That means how many vital failures and how useful many failures you got it from the Pareto. So once you understand that at what are the failures you got it, how you are going to find out those failures. That site is to 20 Pareto analysis principle. So you can see that there is a percentage around 80% here, which is shown in the right hand side of the graph. So if you consider here, if you draw an horizontal line from the 80%, and if you and you can see that it is intersecting the cumulative percentage of those failures. So it will intersect somewhere here, so that you can clearly understand that. So these are all the vital few failures you need to concentrate on. So once you concentrate on this failure, and if you understand that why these failures are happening repetitively, and where you can see that those failures are contributing for the major maintenance cost and having an highest failure rate. So this is how we need to get it, and we need to classify the vital failures and the useful many failures. We need to neglect it, and once we done the high level RCA, then we can eliminate those dominant failure modes, and we can improve the performance of an asset. So coming to the Pareto, so how you are going to prioritize the bad actors for your program. So every organization will have their own principles to follow, that to fix an priority level for the failure numbers. So you are seeing that an asset, so that you can take any asset. That is, I took an example of a compressor. So you need to look at the failure mode and how much downtime hours you got and how many failure numbers you got. So you need to understand that how much downtime hours happen because of the low lube oil pressure due to the lube oil filter pluggage or lube oil filter choking. So whatever the issue, whatever the problem identification you have found it out, and whatever the fault you have been associated with your asset, you need to understand that failure numbers. So the failure numbers are the if you fix on a failure number, so more than 3 or more than 5, so you can fix on a priority level, and you can work it on the dominant the failure modes which are happening repetitively in your organization. So you try to list out the bad actor priority first. So, and once you have been done the bad actor priority, it is very easy for us to classify the dominant failure modes and to look after those dominant failure modes for a corrective preventive action. So if you see this one, I made some rule of thumb and the rule of guidelines for performing a defect elimination. So the defects and bad actors among the facility equipment or the population generally follows the Pareto law or the Pareto principle. So we know that 80% of the consequence issues derives from the 20% of the causes. So we can easily understand that the 80% of the consequences, the dominant failure modes, which is happening repetitively and having an highest failure rate. And so because of those highest failure rate, we are going to have a low MTBF on our asset. So if you are a maintenance and reliability professional, our ultimate aim or ultimate objective is to improve the mean time between failures. So we need to derive that, and we need to classify those 80s to 20 consequences for those failures, and we need to work it on preparing our bad actor database for all the populations, the list of assets we have in our organization. So not only that, we need to understand that some of the failures or failure causes have been identified previously in connection with an equipment or a machine component failure mode, which can give rise to the bad actor behavior. So that also we need to consider that. Consider for us to make a bad actor program. So for a defect elimination, the bad actor report all external failures which are less than 3 numbers or and the planned uh, stoppages stoppages were not considered. So we need to understand that so we need to consider some of the failures which are happened less than 3 times, where those failures are not having a not having an highest maintenance cost and having a low downtime. So we are not supposed to consider as an a priority bad actor. So if you are having a failure mode more than 3 times, so the external failure modes which are reported more than 3 times, and you got a downtime and you got the maintenance cost and the production loss for you consideration. So we need to take it the consideration as a bad actor for us. So we need to work it out on that particular failure mode, and we need to try to mitigate that particular dominant failure mode, and we need to have a corrective and preventive action. So which is not supposed to happen again for the assets. So so the recommendation, so what I've been recommending it from my side. So the identified failure modes of priority one needs to be investigated further. So, and if required, we need to initiate an higher level RCA. An high level RCA will be conducted. So we know that when we conduct an high level RCA, we'll be working on the failure mode, the dominant failure mode. And then we are looking at why the dominant failure mode happened. So what all the failure hypotheses associated with the dominant failure mode. So whether that failure mode happened because of a physical cause or a physical damage, or because of a human cause, or due to the latent cause. So we need to conduct an high-level RCA, and high-level RCA will investigate that the list of priority one failures. So we can conduct an high-level RCA, and we can come out with a corrective preventive action for the improvement of a performance of an asset. So the second thing we need to do we need to identify the failure mode of priority number 2, and we need to investigate if the frequency increases beyond 3 numbers in future. So as I told you before, that we need to fix a priority, that we need to look at that failure mode which has happened more than 3 and having a more downtime losses. As a rule of thumb, we have considered as a priority 1. So once we are looking at the priority number 2 failures, so we need to investigate that if the frequency increases beyond 3 in future, so we need to bring those failure modes into priority 1, and we need to reinvestigate that why that failure was happening, why that failure was happened, and why the priority has been increased. So the recurring failure modes which implemented after the RCA recommendations will be reinvestigated for reviewing the effectiveness of the corrective preventive actions which are missed out as a factor. So we need to look at the implemented RCM recommendation. So we need to look at those recommendations, and we need to look at the effectiveness of those implemented recommendations. So the same event of the failure mode which is not supposed to happen again on the asset. So this is a recommendation from the bad actor analysis. So coming to the last slide here. So the defect elimination program will be focusing on the asset with large maintenance cost and the repetitive failures. So the program will initially consider the PM0102 incidents. However, we'll consider PM0304 events to optimize our preventive maintenance frequency. So your bad actor database and the defect elimination database is an excellent tool for you to go for a living RCM program. So if you want to update your RCM strategy, and if you want to do the preventive maintenance optimization study, so the data, the input you are getting it from the defect elimination program will be highly useful for us. So in order to optimize the PM frequency, so for the PM and the PDM frequency, we can easily list out once we have had a very good database of bad actors, so that we can optimize our PM program, so that we can see the effectiveness in implementation of all those recommendations related to the bad actors. So definitely it will help us to improve the performance of the asset. So this is not a one-time activity; it is a repetitive activity in the organization. So each one of the people who represent your organization, from operation, production, maintenance, everyone has to take a responsibility, has to come front, and they need to form a charter, and they need to have a steering team, and the awareness should be given to all the frontline employees like maintenance supervisors, maintenance technicians, field operators, and so every one of the people who represent as a frontline employees in your organization need to give an awareness on the bad actor program. So once to have a good bad actor program, we need to have a good failure history, and we need to interlink the failure modes and the failure codes. So whatever the CMMS program we are using it in our organization, um, we need to understand that how we are going to concentrate on the defect elimination program. So that is very, very important. That means everyone who represent your organization needs to give an awareness training that how to raise a accurate failure notification consisting the clear problem identification, so the work identification will be done by any of the people who represent your organization. Any one of your organization can identify the problem and how they are reporting it. That makes sense for us to have a clear database for us to implement the bad actor program. So if you have a good failure history and a good bad, if you have a good failure history and a good failure data, so that we can clearly we can clear out our data and we can make out the priority list and we can apply the Pareto principle and we can find out the vital few failures and we can work it on the high level RC. So we need to form a chatter and we need to give an awareness to how to raise a failure, how to identify the problem and how to raise the failure notification with a proper failure code and representing the failure code and having a good failure mode description in the each and every notification. So the time of the event. So once we get a right data, so that we can work it on that how we can work it on and optimizing the strategies and optimizing the recommendations for the problems which have been identified. So the plant, we need to provide an awareness. So the plant management team has to give an awareness. So uh, so once we have given awareness to all the people who represent our organization, so we can have an healthy implementation of an defect elimination program. So it's one of the easiest reliability methodologies to work it on. So we are having a lot of reliability methodologies to follow. So some of the people may call the bad actor program a defect elimination program, called as a vulnerability threat analysis program. So what are the vulnerabilities present in the organization? So some people may call mitigate threat analysis program to find out all the threats in terms of production related failures and the maintenance related failures. So so we need to find out all the threats and we need to have a mitigated corrective action for all the threats. So each and every threat have a problem. So each and every threat will be called as a failure mode, and each and every failure mode needs to be mitigated with a proactive recommendation. So we need to follow the proactive reliability culture for each and every dominant, for each and to eliminate each and every failures for our to improve the reliability for the assets. So thank you all. So thanks for listening listening this webinar for another 20-24 minutes, and I will take on the questions if you have any doubt on this my presentation. So thank you, maintenance community, for doing this opportunity. So we'll see the question and answers.
Awesome. Yeah. Well, thank you, Vinoth. We had many questions come in throughout your presentation, so I'm excited to kind of dive into those with you now. Yeah. Let me just scroll back up and find the starting point. A question here from Ahmed says, how many failures are there in the category of over 10,000 US dollars in your experience?
Yeah, he has asked me an excellent question. So we have got around 3 to 4 failures. So as a rule of thumb, we will consider the 3 to 4 failure modes. So where we have seen that the emergency and corrective maintenance which has led to that. So that's why I considered that as a priority 1 failure mode. So it will give an idea for us to classify those things and we can take it to move forward. So if you got more and more failures, so we can bring that failures from priority 2 to priority 1. So then we can have an high level RCA to find out the dominant failure mode, to find out why the dominant failure mode is happening again and again. So how we can eliminate those dominant failure modes.
Awesome. Yeah. Next question here from Sanjay. How is priority given to fail, or how does priority given to failure modes convert into a dollar amount? Yeah. So we know that for doing a preventive maintenance, we have some X amount of cost to the organization. To do predictive maintenance, we have some X amount to the organization. So for each and every failure mode, so we are going to spend man hours, we are going to spend our spares, so we are going to spend on the downtime. So try to consider each and everything. So what will be your production loss? What will be your maintenance cost on the day you are spending? You are not going to do the regular activity. So as per the CMMS, you are not going to do the planned maintenance activity or the planned predictive maintenance activity. So try to look at these things first. So try to look at the manpower cost you spend on the corrective and emergency notification and what spare you have consumed. So this is not your pre-planned maintenance activity, which came from the FMEA recommendation or RCM recommendation. This is somewhat the failure which has happened from you, and where you can't able to find out from your existing strategy. So then only you are going for a bad actor. So you have got an excellent reliability strategy with you, and you have got excellent FMEA. So you have excellent maintenance plan. So still the failures are happening. Then only you are going for an analysis and improvement activity.
So maintenance cost spent on corrective emergency notification, and that's cost of spare and the loss of downtime. So these are all three key inputs for you to work it out on with. So once you have been working out on these three key things, then we can easily filter out and we can have a good database for us to work it out on. So it will be excellent database for us to improve our reliability strategy in terms of RCM FMEA strategy, to do it after 5 or 7 years. Once we implement it for a plant, then we can do it for sure. Yeah.
Awesome. Yeah. Next question coming up here reads, what tools and analysis can be used for bad actor management?
What tools and analysis? Yeah, excellent. Yes, I think that Pareto is an excellent tool for us. So we are having only Pareto. So we don't have any other tool that to use the Pareto for us. So so if you take any asset, so we know that so we have ISO taxonomy. So yeah, to understand the fault code and failure mode. So if someone don't know the difference between the failure mode and the fault type symptom code and all, so they need to refer ISO 14224. Then they need to understand the CMMS database, the CMMS failure history database. Then we need to use the Pareto. The Pareto is the only analysis tool. So there are a lot of templates available in the Pareto to do perform a Pareto analysis. So we can, if you browse it, we can get it. If it's required, I can post it in our Slack also. So I made an excellent template. So once the rest of the community people who join our Slack community, they can download the template from us. Yeah.
That's awesome.
Yeah.
Next question, kind of continuing along the Pareto conversation. Do you have any real-time analysis data based on the 80-20 for a chronic problem? For example, for a compressor or a steam turbine? Perhaps not something to show live, but maybe something you can follow up with in the community as well.
Yeah. You can follow us on our community. So actually, so the thing he has asked me that real-time data. A real-time data analysis will help us to do the analytical study. So whether our reliability is improving or not, we can do variable analysis to understand what. What kind of failure pattern my asset is following. So whether I had infant mortality or a constant random failure or a wear out failure. So I can understand. I can follow with the real-time data analysis. I can do reliability growth analysis, whether the reliability improvement of my asset is improving or not. So whether my MTBF has been improving over a period of time or not. So whether I have reduced my failure rates over a period of my time or not. So the real-time data analysis will help us to do the lot of reliability analytics studies. Still, the 80-20 problem. So we need to develop a database from our CMMS system. So I have done it for my lot of assets which I have done it before. So we have seen the cost-saving benefits. Even for a small pump, if you have saved around $10,000, $20,000, also it's going to on over a period of time, it's going to save more. So more and more for the organization. So so I made a template for it. But so there's one simple template will be shared on the Slack group for a pump. So I'll be sharing it on the Slack. So you can go to the Slack and we can take it for the pump. So for high level thing, so definitely we are coming up with a reliability analytics program. We'll show the real-time data analysis, how to do it. Yeah.
Awesome.
Yeah.
Trying to filter through my questions. Sorry. The next question here is, can we look into the design capacity and compare it with the demand? Normally, deviation on equipment capacity leads to premature equipment failure.
Yes. Yeah, this was an excellent question. Yes, asked me that. So you asked me during design phase. So defect elimination can be implemented during design phase. So we know that an asset life cycle, a typical asset will have around 6 phases, like from concept, design, acquisition, procurement. Then we go for installation, commissioning, then operation, maintenance, and the disposal. So if you see, once we have been getting into the operation and maintenance phase, so then only we can understand that once our assets started operating and once our assets started generating a revenue for our organization, then only we can understand that what kind of failures are happening to us. So we are doing a design FMEA, and we are doing design FMEA. We are doing a lot of design activities. We are going for a design selection, lot of design things we are doing it. So before procuring our, before installing our asset. So asset is going on various phases, the design and development phase, and asset is going for a factory acceptance test, and asset is going for a site acceptance test. So we are doing a lot of things before when you are operating your plant. So initially when you are putting up your new plant. So it will the defect elimination program will be effective during only the operation maintenance phase, as we do the root cause failure analysis only during an O&M phase. So we can use the defect elimination program during a design and effect phase. So what Mr. Flex is asking me, excellent question, that so if you see the cause and effect chart, so the OEM, the vendor of the company, used to develop a cause and effect chart. So that is completely different from a defect elimination concept. So in the cause and effect chart for each and every problem, so we have a troubleshooting guideline that what will happen, so what we will do. So that will be developed during a design phase. Design phase we will do cause and effect chart. So when it comes to the operation and maintenance phase, then we will implement all the reliability methodologies. As I told you, like bad actor program, defect elimination program, RCM, FMEA. So every program will come once we get into the O&M phase. So in the design phase, we will get only cause and effect chart. So we don't get anything apart from that. So that is the only input we are having. So yeah, that too will be reviewed by the design professionals, not by the maintenance and reliability professionals. Yeah.
Awesome. So am I correct? You're just answering Felix's question as well?
Yeah.
Perfect. Okay, great. Yeah. There's a handful more in the questions tab here still. The next one I'll ask is, can you differentiate between the quick failure, a gradual failure, catastrophic failures of any rotating equipment with any examples?
Yes, excellent. It was an excellent question. I've been expecting this. So if you can look at the quick failure modes, so you can see that, so where we don't have a time, that means we don't have an approximate PF interval. So you can see that a sudden increase in a bearing temperature. Bearing got smoked out. So the bearing temperature has increased, and we got a smoke from the bearing. So we don't have the time. So that was we don't have any interval of time that to see that. So it was not a random event also. It's a one-time event. So usually we will see that even we don't have a time and we don't have a PF interval time also to fix it, that it was happened in a span of time. If you look at the gradual failure, so if you see that so any of the failure related to the lubrication, so the failure is not going to be the one-time activity. So whenever you see the lubrication kind of failure modes, the increase in water content in your lube oil, or the contamination of your lube oil, so definitely it will be a gradual failure mode, and you have got a PF interval. So if you do the vibration analysis, if you do the lube oil analysis, and you can easily find out that what kind of contamination is present in your lubrication. So it is having some time that we can easily see that over a period of time, that how this failure is gradually going to reach the functional failure and the catastrophic failure. So you have got some time to plan your predictive maintenance program in such a way that you can easily you can go and you can attack that particular dominant failure mode, and you can mitigate it. But when catastrophic failure is something we can tell it that you lost on a complete function of your asset. So the catastrophic failure, if you see that, so we know that the degradation mechanism associated with an asset. So some of the asset, so if you have not been implementing any reliability program to our asset, if you have not done any maintenance program for our asset. So let us take an example that you have a pump that you have not replaced the lube oil for over a period of 2 years. So the same lube oil or a period of 1 year. So you are having a pump where you are having a mechanical seal flush and a mechanical seal coat oil to be replaced. In the maintenance perspective, I'm talking about it. So if you are not at all taking care of your asset, so we need to look at our asset and we need to see that, and a catastrophic failure is like a one-time event. So sometimes we can see the failure which is having which is going to create a more cost for it. Let us take a simple pump. 1/3 cost of the pump will cost you for a mechanical seal, and 1/5 of the cost will cost you for a bearing. So if you have not done anything, if you have not planned any maintenance program for your asset, and if you are not having any kind of PM program, so we can't able to get it out the things into the bad actor program. So we need to clearly observe that. So we need to clearly understand that. So such kind of failures definitely going to have a catastrophic event. So we are going to see that kind of failures for our assets. So we can't able to mitigate those failures. That's also possible. Yeah.
Awesome.
Yeah. So I got an excellent question from Mr. Girish Kamal. So he asked me that do you think that instead of number of failures and cost of failures, better to measure the define a bad actor example, that there is only one failure that cost you 1 million USD as compared to the 10 repetitive failures just cost us the 10K USD. Excellent. So this is what we are using a Pareto to classify the failures. He has asked an excellent question there. So when you look at the time of events, so the time of events, some of the events are significant, having high risk. It's a one-time event which you told me that as a catastrophic failure, and I got the failure of a bearing or a failure of the seal in my compressor, or any kind of a critical component which has got failed in my asset. So a defect elimination program is a continuous improvement program. So here we are doing an analysis and improvement activity for us to find out the dominant failure mode which is happening repetitively for the asset, and to come out to the corrective and preventive action. So in this scenario, we can eliminate the defect elimination program. So what Mr. Girish Kamal has told it, we can conduct an high-level RCA. So then high-level RCA will be performed. So the high-level RCA team will be taken into the consideration for the one failure which has cost $1 million for an organization. So because the cost of failure is more and the event which has created to the organization is more. So that one event, a failure cost of $1 million could have brought a production loss of 3 days. The compressor could have been not available for 3 days for the production, and they got a more mean time to repair for the particular activity. So definitely it's going to do it. Definitely it will be considered as an high level RCA. So we can bypass the defect elimination program. We can directly conduct an high level RCA for that thing. Yeah. So
awesome. Yeah. Looking at the next question in the line there, does application of the Pareto Principle in defect elimination conflict with relying on the RPN in decision making, and how might that conflict be reconciled?
Yeah. Actually, yes. Yeah, you have asked me the very good question. But RPN number, we are using it with doing for an FMEA analysis. So we don't have anything to do with the defect elimination program. It's a simple program to implement and to see the effectiveness of implemented recommendation over a period of time. So if you develop the maintenance FMEA, if you want to develop the maintenance FMEA, so your maintenance FMEA will be a great platform for you to develop a maintenance plan and a maintenance strategy. So we have an excellent CMMS system. We have very good CMMS system. So definitely we are capturing all the failure codes and failure modes and all. But coming to the RPN number will be only useful for us to look at the risk associated with each and every failure. That means the risk priority number. It's talking about the severity of the failure and the occurrence of the failure and the direction of the failure. It will be useful for doing a design FMEA and maintenance FMEA. So sometimes you could have forgotten to capture the dominant failure mode when you are doing FMEA. This was happened for me also when I would develop the RCM FMEA strategy for my asset. So I've done it 5 years back or 7 years back. That time I've considered the failure modes for the asset, and I've implemented my maintenance plan and maintenance strategy. So my assets start operating, and around 3rd or 4th year or 5th year, I found out that some failure mode which I have not covered in my existing strategy. So my existing FMEA, I have not covered it. So what will happen? That time I need to capture somewhere. So for that I need to have a program, right? That's why that's why some of the reliability methodologies we have been following it. So that's the reason we need bad actor program or a defect elimination program to capture all the failures. Then once we go for a revalidation of those strategies as a living program, so as a living RCM or a living FMEA, we can put it out the things in our passion, so that in our database, so that we can consider those failure modes. And again, once we are considering that, and give a high RPN number for that, and try to mitigate those failure modes and try to have a good maintenance strategy, so that we can have all the failure modes covered under our own maintenance plan. So this can be done, but RPN is clearly related to FMEA. It's nothing to do with defect elimination.
Awesome.
Yeah.
I think let's take maybe 2 more questions. I know we're still getting a few more, but let's take maybe 2 more questions, and then if you have any other questions that either didn't get answered or that you're still wondering about, feel free to connect with Vinoth in the Slack community. So second to last question here is, what about after the RCA method? If the root cause leads us to business management, how would we handle such a case?
Yeah, definitely. So the same question is related to Mr. Girish, as I asked. He's told that the $1 million scenario. Whenever you do the high level RCA, so the involvement of stakeholder contribution will be more, because we are clearly talking about a business improvement. It is an high level activity which has lead to some fatality incident inside the plant, or some of the catastrophic failure which is related only to the asset. So how much cost, the risk involved? It's not the cost, how much risk involved in that one. So it's not about completely a cost. Now we are talking about a risk. So we have find it out that on a high level incident which has happened created a fatality and lead to the catastrophic failure of an asset. So we need to look for the high-level RCA, and we need to look at the we need to have a stakeholder involvement. Sometimes we need to have a high-level we need to hire a consultant to perform the RCA. So definitely the people who involved in the same incident and the people who are from outside of the organization will have a lot of difference in providing their opinion. So once that incident has happened, which is having a significant damage and a significant risk for it, so definitely we need to go for go to the high-level RCA with all the stakeholders to be part of that particular RCA for a business improvement activity. So definitely in that scenario only we are going to look the failures on the risk point of perspective. So otherwise we can't able to see that. So we need to consider that thing. So that the stakeholder expectation is very important in that scenario. Yeah.
Awesome.
Yeah.
And then our last question that we'll answer live today. I know we've been answering questions for a while now. Thank you so much, Vinoth, for all your wonderful answers.
Yeah, no, sure. Yeah.
The last question we'll go through today reads, what are the KPIs to use to measure the effectiveness of a bad actor or defect elimination program?
Excellent. The percentage of failures identified, that is one of the most important KPI. The percentage of failures identified from each and every department. So we have a lot of people involved in our organization. How many percentage of failures have been identified and how much percentage of failures will be contributed for the organization? Once we have identified that, then definitely the first KPI will be the percentage of failures we are identifying in the organization. That's the most important KPI. And the second thing is that how many failures for those how many failures we have given a corrective preventive action. The list of corrective preventive action we have given for those particular dominant failure modes. How many failure modes we have eliminated? So how many recommendations we have implemented? So definitely we have a time frame. So on a year we are finding out around 20-30 bad actors. We are generating a corrective preventive action for that, and how much time frame we took it to close those corrective actions. So how many we are implemented? How much you are finded and how much you are implemented? So finding the problem is easy and implementing the solution is difficult. So anyone can identify the problem. So that's what I told you, that an identification of problem is something different, but implementing a corrective action solution is something different, because some of the problems we need an engineering modification. Some of the problems we need an engineering study. Some of the problems can be solved within the internal team, the internal expertise and the reliability champion and the functional champion within our organization. So the list of percentage of failures we have identified and percentage of corrective recommendations we have generated from, and the percentage of the corrective preventive action we have closed for the identified dominant credible failure modes. So these are all the most important 3 KPIs to be considered. And most important thing, that we need to reward the people. We need to reward each and every employee who are finding out more and more problems in the organization. Then only we can create an enthusiasm among the people to implement this program. Yeah. So,
awesome.
Yeah.
Wonderful. Well, if you haven't seen it, there's a lot of thank yous going off in the chat as well for a great presentation. And I, again, really appreciate the thought you put into not only the presentation, but this Q&A session. It's been, almost 20 minutes now that we've been asking and answering questions. So I know it's getting late for you. So
no issue. Yeah, I'm available. Yeah, I'm available to explain. Yeah.
Awesome.
Yeah.
Well, thank you again, and thank you for all of our attendees who joined and stuck around for that long Q&A as well. If you do have any further questions for Vinoth, I'll drop the link on how to join Slack one more time, and he's really active in there and available to answer any other questions.
Yeah.
Awesome.
Yeah, sure. Yeah, we are coming up with my program will be next with maintenance community will be reliability analytics. So it will be most of the interesting concept. So we are sure I'll be coming in another 1 or 2 months for it. So I just want to thank the maintenance community for bringing this excellent webinar session to all the people to have a knowledge platform to share. So it's very difficult to get a knowledge these days, and the maintenance community is helping all the maintenance and reliability professionals across the world. So I just want to inform all the participants, please join our maintenance community and the Slack community to explore. So thank you, Vinoth. Thanks for this opportunity. Yeah.
Awesome.
Yeah.
Thank you, and have a great rest of your evening. And I will see everyone next time.
Yeah.
Bye-bye. Thank you.
Bye.